Hi, guys. Welcome back to part two of Unit 6, Lesson 1, which is our introduction to matter. Hopefully, you're getting kind of the hang of this all. Matter, anything that has mass and takes up space, the difference between mass and weight. And now today we're going to look at volume and then density. So let's start out with volume. Okay. So, how is the amount of space occupied measured? So, anything, for instance, this candle, anything like that that takes up space, that space has a name and it is volume. Okay. And there's different ways to find out the volume, and we'll do that in just a little bit here. Hey, objects with similar volumes do not always have the same mass. The example they give is a golf ball and a tennis ball. Obviously, a table tennis ball, sorry. A ping pong ball, table tennis ball is obviously hollow. Okay, so it's to have the same volume as a golf ball, but a lot different mass. Think about a basketball and a bowling ball, same thing. Okay, so this is a question that you're going to need to know whenever we have our next quiz, because it's a major question. What does volume measure? So think about that for a second in your head. And it is, as we just said, the amount of space an object occupies. All right, so there are different ways that we can determine volume. There are three main ways. First of all, anything that is well defined, like has sides, like a cube, a rectangular prism, like a shoebox, can be measured simply by measuring the length by the width times the height, L times W times H, and just do the math. Nextly, there are things that aren't shaped with well-defined sides, okay? An irregular shape, like a rock, a toy, anything that doesn't have a definite shape can be measured by using the water displacement method, which we will look at later. And then lastly, liquids can have volume. For instance, a 2-liter bottle of soda, okay? And that can be measured using a graduated cylinder. Okay, again, for something with straight edges, for instance, this book, the formula can be used to find the volume, just simply length times width times height. And make Mrs. Pratt proud and remember that so that you know that when you get to it in math. Maybe Mrs. Higgins already talked about it last year. Okay, so here we have a sample problem. Let me just move that up here. Okay, so as we go through these problems, a lot of times they're going to ask you what you know. Well, we know the length of her lunchbox and the width and the height. Okay, so they suggest that you draw a label and sketch it, which is shown here. And then just write down your formula. Again, L times W times H, length times width times height. Okay, and then just simply you can use your calculator always, and you would get your answer of 4,500 centimeters. Now, because you're in this case dealing with 3 different items that are all centimeters, it's centimeters cubed. Just like with squared, you would have a 2 up here, it's cubed, so they are given a 3 or a cubed. Okay, so next we have, and my picture is in the way again, we have, oh, that's perfect. We have a locker. Unfortunately, right now you guys can't use your lockers, but maybe before the year is over. But they have the dimensions of a locker. So it is 30 centimeters wide or long, they say, 40 this way deep from the front to the back, 40 centimeters wide, and 200 centimeters tall. So it's going to ask you what you know. Well, we know the dimensions, 30, 40, and 200. Next, what do you want to find? So say to yourself, what do you want to find out? Well, we want to find out the volume. That's what this is about. So if you have paper around, you can draw a quick sketch and label it. If not, picture it in your mind. Okay, but there, ooh, that's a nice sketch. Okay, so there's a sketch of the locker with the dimensions. Now, which formula are we going to use? Take a second, say it out loud. Hopefully you said length times width times height. Okay, so now just like in math, we're going to sub in these numbers. So our length is going to be 30, our width is going to be 40, and our height will be 200. Okay, the parentheses mean multiply, just as a review. I'm sure you know that, just so you know. So then we take out our calculator, use a calculator on our iPad, and that's 240,000 centimeters cubed. Again, make sure that it agrees, centimeter, 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 cubed. Okay, so there you go. Those problems that for objects with set dimensions are really fairly easy if you know the formula. All right, here are some pictures of some graduated cylinders. And they are tools that we use to measure the volumes of liquids. So different volumes here will give you different amounts. Okay, they can be used to find the volume of irregularly shaped objects like rocks. Okay. All right. So what you would do is drop the irregularly shaped object into the graduated cylinder, and then you can measure its volume by the amount of water it displaces, or the height that the water goes up. Okay? So units for volume is usually milliliters, and solids are centimeters cubed. Okay? And they're going to show you real quick, converting from liquid volume to solid volume is very easy. And it's 1-to-1. Okay, so 1 milliliter equals 1 centimeter cubed. So you could place 1 milliliter of liquid into the 1 centimeter cube that he's holding. All right, so let's look at this problem here. Two images, the two images over here, it says below, but over here, show a graduated cylinder filled with water before and after a chess piece is placed inside. Use the images to calculate the volume. All right, so this is really very easy, not even any math. So the volume without the chess piece over here, so no chess piece, is 40 milliliters. We put the chess piece in and it goes up to 46 milliliters. So the volume of the chess piece would be, say it to yourself, 6 is right. So it would be 6 milliliters, because those are both milliliters, but that would also equal 6 centimeters cubed, because the chess piece is a solid. All right, we're going to start density, and then we'll continue it at another time. Density is very, very important. Mrs. Divish in the 8th grade will talk to you a lot about it. Okay, density indicates that how mass and volume are related to each other, for they both help us calculate the density. All right, density is the amount of mass in a given volume. It is the amount of mass, how much mass you have, over how much space it takes up. Okay, so density will not change no matter what the shape is. So if you take, for instance, this little knickknack I have, and you found its density, if I there we go. If I sawed it in half, it would still be the same density. Okay, and the example is if you rip a piece of paper in half, the density will not change. Okay, we're going to stop there for today, and we will pick up either Thursday or Friday with these questions. So there will be just a few questions after this. So make sure you get those completed. All right, thanks.